Sometimes we're able to remove a discontinuity and make it continuous by turning something into a piecewise function. So if I take this function here, it has a removable discontinuity. So what we can do is write it as an extended function that is continuous at the point where we removed it. So basically, it would have a hole in the graph, and we're going to fill in that hole. So if I take the limit of this, let me factor this first, actually. So if I factor this, I have difference of cubes on the top. So this is going to be x minus 1 and x squared plus x plus 1. If you don't know how I got that, it's the difference of cubes formula. Look back at notes, I guess, from Algebra 2 and pre-calculus. You should see that in there. Not something I think you have to really worry about, but it may come up. So when I look at this, I can see that the x minus 1s cancel out. So that's removable. So when x is equal to 1, I have this removable discontinuity. When x equals negative 1, I have non-removable discontinuity. Okay, but at 1, where I removed it, I can fill in that hole. So what we're going to do here is we're going to take the limit as x approaches 1. So we're going to deal with what was canceled out of this function. So x cubed minus 1 over x squared minus 1. Right, we already factored it, and we can cancel out the x minus 1s like we did up here. So what I'm left with is the x squared plus x plus 1 over x plus 1. So now if I plug in 1 and I do direct substitution, this is going to equal 3 halves. So at 3 halves, that's where I have the hole. So what I'm going to do is I'm going to rewrite this whole function f of x as a piecewise function. So the first part, I'm going to keep the original function, so x cubed minus 1 over x squared minus 1. And I'm going to say that that is going to be where x is not equal to 1. So when x is not equal to 1, we're going to use this function. And then the new function we got, we're going to use 3 halves as the function. And that's only going to be at the exact point when x equals 1, because we're redefining it, right? So when I plug in 1 now, I get 3 halves as my value instead of having a hole. So by breaking it into this piecewise function, I can fill in that hole and I can remove the discontinuity. Okay, so let's look at one more example here. So same type of idea. When I look at this, I can see right away there's going to be a discontinuity because the bottom can't be 0, so at 2. But let's try to factor this first. So if I factor this, I'm going to get x minus 2 and x plus 1 over x minus 2. Right, so these can cancel out. So at 2, I have a removable discontinuity. So I'm going to take the limit as x approaches 2 of this function, and I'm just going to simplify it already, and I'm just going to call it x plus 1. So it's really taking the limit as x approaches 2 of the whole function, but because I already factored it up here, I'm just going to carry it down here. So now I'm going to use direct substitution. I'm going to plug in 2, and I get 3. So when I remove that discontinuity, I can fill in that hole and the y value would be at 3. So again, I'm just going to rewrite this as a piecewise function. So the top function is just going to be the original. So x squared minus x minus 2 over x minus 2. And that's going to be when x is not equal to 2. So when x is not equal to 2, we're going to use this function. And then we're going to say that it's 3 at the exact point when x equals 2. So when x is 2, we're going to have 3. So again, this piecewise function will remove the discontinuity by filling in that hole